Hello everyone, my name is Chandrachud Chatterjee, and in the previous tutorial, a very simple basic tutorial, we saw how to syntactically implement a SVM model from the scikit-learn library on a simple dataset, that was the iris dataset, which was also present in the sklearn library, which we imported from the sklearn library. But in today's one, we'll try to understand how linear regression works, and try to use the sklearn library again to import the linear regression model, train the linear regression model on a dataset that we will be using today. I will describe the dataset in just in a few minutes, and we will try to understand how a linear regression actually fits, right? And what is linear regression? Now, a theoretical understanding of linear regression, you might have to go through a bit of mathematical understanding. What are the formulas, and what do you mean by linear regression, and what does linear mean, and what does regression mean, and which kind of data sets are fitted into linear regression, what are the problems with linear regression, what kind of regularization or penalization that we performed in linear regression. These are very important, which you need to go through. But again, in this video or tutorial, I will try to simply show how to import linear regression from sklearn, and try to understand how to work in Collab by training a simple linear regression model and then predicting, and we will try to plot the data that we will be using, and what kind of functions that we have trained using the dataset. We will try to understand and plot them. Okay. So first of all, let us try to understand. In the previous tutorial, I showed how to create a Collab library. We will first go to open Collab, Collaboratory, Google Collaboratory, right? Then we will go to File and open Notebook. So as soon as the notebook opens, let us see. Yeah, the notebook is open, and as you can see, every time you open a notebook, it will be named untitled something.ipynb. Now, this file extension is very important, right? .ipynb. You need to know that this is .ipynb and not a single Python file, which I have already mentioned in the previous tutorials. But again, because very important, it is not similar to a Python file. So when you will be trying to run this .pynb file in a Python editor, it is not simply work like that. You have to convert it into a Python file. Uh, or similarly, when you are running a Python file in Collab, it will not simply run just uploading and running. It will not run like that. You have to open a Collab notebook and then paste the code, Python file code over here, and then run the cell. Okay, so let us rename this Python file. Right? First of all, we will rename it as tutorial tutorial 2 on linear regression. Right. So now, first of all, before doing this, right, let us try to understand uh, when we are trying to rename this, what kind of data we will be using. Now, the data that I will be using for this purpose will have just two inputs, right? X and Y. We will consider one of the inputs as the X input and the other input as the correspondingly Y input, right? So I will show where the data is present and how to mount the drive, because we are not loading the data from any library. It is a CSV data that will be present in our local host, or you can upload it into drive. So first of all, let us try to understand where we are getting the corresponding data. I will show you the links where the data is actually present. Okay, so here, as you can see, this is the data that we will be using. It is the salary data. It is a very thing. It does not have any meaning or much use in the actual practical world, because salary does not depend just on the experience that we are seeing in this corresponding data. So as you can see, there are only two columns: years of experience and correspondingly salary. So for every year of experience, starting from as you can see, it is 1.1, that is 1 year 1 month, to, as you can see, it is 10 year 5 months. The salary, how the salary actually changes, we will use this data. So first of all, you can simply download the data from here, from this link, or there is also an option in Collab. You can import Kaggle data very easily by creating tokens in Kaggle, which we will cover in next tutorials. So in this, for this tutorial, I have downloaded the data. It is, and I have uploaded the data in my correspondingly drive, right? So if I open my drive, as you can see, I have the corresponding data downloaded. So when you download the data, it will be in zip format. So you have to unzip it, and the corresponding data is at salary data.csv, right? So now what we will do is, We'll come to our Collab library or Collab notebook and try to use this stuff. First of all, let us try to learn how to mount the drive onto the Collab notebook, right? Which is very important. Mounting the drive so that you can access everything that is present in the drive directly into the Collab notebook, right? So there are two simple ways. First of all, I will show you the very simple way, and the other one which we used to do previously few years back, but now Google has improved this, upgraded this, integrated this new feature. So in the Collab library, you will see this folder logo. You will just click this folder logo. It will try to allocate a runtime, and as we are using simple machine learning algorithms such as linear regression, we do not need huge runtime. Simple CPU processing will work. So first of all, as you can see, the runtime and this particular thing opens. Side tab actually opens. Now as you can see, this is the third option that shows the drive logo in the folder option. So as you can see, when you hover over it, it shows mount drive. So you can click it, and you have to permit this notebook to access your Google. So you can just click connect to Google Drive, and in just a few seconds you can see that the drive option appears over here. Now, as soon as the drive option appears, you can simply access drive, my drive, and everything that is present in your drive. So, as I showed, the corresponding dataset was present over here. If I go to the dataset, yes, this CSV data is present, right? Or there is another way by writing programs, we can actually mount the corresponding drive. So, for that, you need to import a library which is known as from google.mount import drive, and then you have to do drive. So it should be from google.collab import drive, then drive.mount, and correspondingly it is written as slash content slash drive. Right. So when you execute this, yeah, so the same notification came that connect to Google Drive. As you will click that, you have to select the corresponding mail account which you are logged in with, or the corresponding dataset that is present in your particular drive account. So you have to select that, and then you have to specify allow, and simply it will be mounted. As we are already mounted in this using this option from the folder and button clicking option, it will show the drive is already mounted, right? So now let us have some imports are very necessary. So we'll have some popular imports such as numpy to treat everything pandas to read CSVs, right? We have import matplotlib, and qlt. We have import scikit-learn linear model, or we'll write it as scikit-learn dot linear model import linear regression. Now you can always search it simply in Google, and it will show you what is the import for the particular sklearn library. So we'll use this following import first, and then we'll see what we need, and then correspondingly we'll do that, right? So let us try to understand the dataset first, and why this dataset is used for linear regression, and what is linear regression, right? Now, first of all, you have to for a depth or a deeper understanding of linear regression, you need to go through a little bit of theory or mathematical understanding. I can show you. I have a blog or an article on this particular topic as well. So I will just go to my website. You can also look into my website. I will go to blogs. Simple mathematical understanding of linear regression. You can simply go over there. It will tell you what linear regression is. This particular diagram. Remember this diagram. We will have a diagrams looking similar to this, a little bit different, right? So mathematical understanding of the linear regression you can easily get, and what are the corresponding regularizations and everything is present over here. You can easily read that and understand. It is very easy. So let us try to understand what the data looks like, right? So we'll call it data frame df, then the read csv function to read the corresponding data. Now after importing the drive, as you can see, you can just simply go to that particular file, you can copy path, you can you can press Ctrl V and simply the path will be pasted over there and the data can easily be read. Now if I do df, I can if I print the data frame, you can see the data is present like this. So first column is years of experience and the second column is salary, and there are total 30, I think it is 30 because it starts from 0. So there are actually 30 such entries for this particular data set, right? Sure. Now, as the data is present in the data frame, in a data frame format, we will try to split it into numpy arrays. So first of all, that we will try to split the data frame into first column, which will be the data, which will be the x, and the salary is what we will try to predict, right? So both are actually real and continuous values over here. That is why we are using linear regression, not any classification, because there are no discrete classes or labels. It is a continuous value. As you can see, salary starts from 39,343 until 121,872. Right? So it is very continuous. There are continuous values, so we will try to use linear regression. So before that, let us try to understand what the data looks like. Right? So first of all, we will try to have the years of experience into the x variable, because we input the years of experience and we expect that will print out a salary with a very close with a very less error corresponding to the data set that we will be using to train the model, right? So we will do df dot ilog function, and I want to take every value from 0 to 29, right? For every 30 rows, I want to take every value. So I will give column that indicates all the values from 0 to 39, and then I will have just the first column that is 0, right? So if I do this and then I print x, you would see that only the years of experience are present over here. Now the thing to look after here, that it is still in data frame format, not in a numpy array, which is our objective, right? Whenever we try to fit it into an AML model by importing from a scikit-learn library, basic necessity is that it should be in a numpy array, not in a data frame format, because it makes it a little bit harder or very difficult. It cannot actually process a data frame kind of file directly, so it needs to be converted into an array format, and especially numpy array format. So what we will do is we will do x equal to np dot as array and x. Now if we print x, you can see that it is a simply array with the corresponding years of experience values, which it will treat as float values because they are already in corresponding decimal representation of float, right? In float representation. So x has been converted, the years of experience has been converted into corresponding x variable. Similarly, we will take y, and it will be the y equal to df dot ilog, all the values from 0 to 30, and the last column, so we will put minus 100. Now if we print again y equal to np dot as array, we will do y and then y and print. So you can see that it has been converted into an array containing 30, 0 to 30 values, right? Correspondingly. So as you can see, x and y has been converted. Now let us try to understand what this data looks like, right? So what we will do is plt dot scatter x comma y. Now this function, what it does is, it is a function present in the matplotlib.pyplot, as which you have imported as plt. So what we will do is plot the corresponding x values into x-axis and the corresponding y values into y-axis, giving us a a two-dimensional plane where all the points will be plotted. So right, let me run this. You can easily visualize this. So now when I run this, you can see that every data point, there are 30 points on this particular data set, and every point has the corresponding x value and the y value printed over here, right? You can also print it in the corresponding line format to understand better. Scatter, I'm sorry, x comma y, and then we can do plt dot show. Yeah, so you can see the corresponding connection to this is the corresponding data set that you will be using to learn a linear regression, or what you say mathematically is to fit to a linear function. This is the data that we will be using to create a function that is linear and we'll try to fit this data into the particular function, right? So now, first of all, as we have already got x and y, now the first step is to split the data, and I have already mentioned how to split the data previously. So we have not imported the corresponding function for splitting the data, right? So let us import that from s dot model selection. Let me see that model selection import test split. Okay. So we'll run that because we'll load the new command from there right now. Let us split the data. Explain comma string. So we'll pass the corresponding x and y values. We'll pass the test size, which will set as 0.3 corresponding to 30% out of the 100% data. So if there are 30 data points have been mentioned, therefore 9 data points will be used for testing purposes and 21 data points will be used for the training purposes. You can have it any value, you can have it 50-50, 80-20, 75-25, anything. And uh, moreover, one important thing you have to mention that we do not need stratify over here. We can have just the random, not ransom, random state. You can mention random state to be any value. Would not need the stratify because it is not a classification task. There are no specific classes based on which it will try to stratify and prevent class imbalancing, right? So it is regression function, so we do not need any stratification function, right? So extend, extract, everything we have written. So let us run this. Now let us print the shape of the extend and see how many values are there. Yes, so there are 21 cross 1 values, and similarly it is void dot it should also have 21 values. Yes, simply 21 values, and this is a 21 cross 1 dimension, right? So this is what we will be trying to what we will be trying to predict is the corresponding y value for this x value. So now let us run the corresponding linear regression or import the linear regression. So what we will do is model equal to linear regression. Yes, and simply we will not try to look into what are the corresponding uh, parameters that you can use in linear regression, which are very important, which you can go through in the theory. But today we will simply use just the default linear regression. There are also some default parameters that are used in linear regression, which you can go through. Linear regression in scikit-learn. You can simply go over this document and you can simply understand what are the parameters, what does this intercept, normalization, everything, what does it stand for, rank, singular intercept, everything. You can go through there. You can also, yes, also these values reach, what is lasso. I have made blogs over reach regression, and I don't think I have made a blog over lasso regression, which I will post, don't worry. So, but a basic mathematical understanding of linear regression, as I have showed, you can simply go to my website and go to the blogs, and you can study here to get a much deeper understanding of how a linear regression actually works, right? So we'll call model equal to linear regression to create an instance of this particular or object of the particular linear regression class, and then we will do model dot fit to fit the corresponding data, and we will be fitting the training data. Now, if you run this, it should simply run without any worries. Yes. So as we have not passed any parameters, it simply printed linear regression. If we have passed our custom parameters or different parameter values, it would have printed those to make us aware what we have used. So now let us try to predict for the tested data. We will simply use the model predict function, and what we will do is we will pass test. That particular predicted values will be present in the y pred values, right? So if I run this now in linear regression, and now in classification case, as I shown, we use the accuracy matrix because it was a classification task. There are classes, but in linear regression there are no such classes. So what we will be using is the squared error. Now, what do you mean by the squared error? Now let us try to go to our blog and I'll try to show you what the squared error means here. Now, as I told, remember this function. Now this is that the blue line, as I mentioned, is the regression. So this is what we have predicted, right? And the black data points are actually the actual points. So if you can see, correspondingly, let us consider that this black point is at 100. So for 100, this particular value is close to 10, but we have predicted it's close to 12.5 or 13, right? So now the squared error would be the distance from this point to this point and the square of that particular value. Now why we take squared value? There are several theoretical reasons behind that, which is also mentioned over here. This is the squared error. This is the function of the squared error, y minus x beta square. You can go through easily that. Okay. So now let us go back to the code. Now as we have all the predicted values over here, we will try to import the squared error function scikit-learn.metrics import. I think it is root mean squared error, or I think it is mean squared error. I will just let's try. Yes, as you can see, there are different errors: mean absolute percentage error. This is the mean squared error. You can need to run it again. After you can just do mean. You can simply just go to type something wrong. No mean squared error, and I can simply pass the actual value, that is the test value y test, that is the corresponding values for y values for the corresponding x test, and the predicted value, that is the y paired. Now if I run the mean squared error, y paired is wrong. Let me see what is the problem. Okay, I have a capital over there. So now you see, this is the corresponding mean squared error, right? Now let us try to understand what we did after using the linear equation, what we predicted. Let us try to visualize what we predicted, right? So what we will be using is plt dot plot. What we will use is x test, because that is what we predicted on, and y test. Right? This is the test data. On the test, this is the line that we actually predict. That thus we simply predicted the corresponding straight line, but the actual training data corresponding of these points. This happens at zigzag pattern, but we predicted this. Now let us try to visualize on top of the training data how our model actually works. So if we have y paired here on train data, so that we can get every data point. Now let us remove these and have plt.scatter train on train, and then plt.plot train one thread, and then plt.show. Yeah. So these were the blue points that you can see were the actual points in the data set, but this is the line, the one that we actually predicted. So this is what we predicted. So for example, let us take a particular value. So as you can see, if we have the Earth have experienced 9.6, then third from the last, the value, the salary should be 112,635, right? So let us try to predict that, predict and see how close we are getting the corresponding value. So it was 9.6, not 9.0, 9.6. Going to print this. Sorry, spelled it wrong. Okay, so now let us see what we get. We get a value of 116,215, but the actual salary is also 112,000. So we are close. Not bad, not bad. So without any hyperparameter tuning, without any regularization, we've got a close actually value by using simply basic default linear regression on. So this is how linear regression actually works. So what is trying to do is actually try to fit the training data on a particular function. This is the function. This is the equation of line, or you can say as a function y equal to mx plus c. with corresponding m and c values. Similarly, in linear regression, we have y equal to wx plus b, where w are the corresponding weights and b is the bias. So what we did is tried to generate a corresponding function to fit the corresponding data without actually overfitting. So if the training data looks closer to this, it would seem it is overfitting, but as you can see, it is not actually overfitting, and it is giving not bad values just for a simple and arbitrary data set with only 30 data points, right? So this was all about corresponding linear regression. So I request you to go and check my blog out there for much more theory, and in the next tutorial or so we'll get into deeper hyperparametric tuning of SVM linear regression and plotting these and understanding what are the corresponding errors and what error functions are used in various functions and what they look like, right? So this was all about it. Thank you very much.